How are you and welcome back. And today we are going to talk about one of the emerging trends in AI engineering, and that is the artificial intelligence protocol called AGUI. So before AGUI, there were other protocols that came into place, and one of them was model context protocol that helped people connect agents to data sources across the web and even in your local computers in databases. And then after the model context protocol, we had a new protocol called the A2A protocol. Model context protocol was brought in place by the company called Anthropic. Anthropic is the company behind Cloud 4 Sonnet series and the Cloud Haiku series and even the Cloud Opus series. So it is the company that is building Cloud, a very well respected and known company in the AI engineering space and AI and machine learning development. So after the protocol called model context protocol that helped us connect to data, people quickly realized that apart from connecting to data, people need to build agents. And agents is something that is very difficult to define because almost everyone has their own definition of what agent is. But as for me, an agent is a system of large language model that can do function calling and can interact with things with browser and execute tasks on behalf of the user. So building agents was a smart move because it unlocked capabilities that were really not possible when it comes to using LLMs. So function calling brought us to the term agents. And now after agents, we needed something more. If you have a single agent that is doing something, for example, it is searching the web or downloading YouTube's transcript, reading them, and then responding to user queries. If you had this agent and then you are building a system that it can do several things, not just handling the transcript, but also searching the web for financial data, analyzing this financial data, and even interacting with code sandboxes, executing code, and then feeding back this executed code. And it has to perform several multiple steps. People quickly realize that it is not possible for this to happen just on a single agent. We need more specialized agents, and that is where the term team of agents came into place. So after the team of agents came into place, there was another realization that if we had a team of agents, these agents need to communicate with each other, and there has to be agent leader or orchestrator who is going to ensure that these agents are in sync. And for that communication to happen, we needed a protocol to ensure that there is a seamless and smooth and standard communication between agents in all of the AI systems that are being built. And that is where the agent-to-agent communication protocol came in, a protocol that was introduced by Google for the purposes of ensuring that there is a smooth communication between agents while they are collaborating on a task. But then there was another problem. If you are now able to make your agents communicate, and not just your agents communicate, but also you are able to connect to data sources in your local computer and outside remote repositories where data is located. The next problem is, how do you ensure that there is seamless integration between your backend and your front end? And that was a big problem because it was not really clear on what you should do, especially when it comes to human-in-the-loop agentic systems where human need to provide some input or supervision as the agent continue to execute on a single or multiple task that has been designed for him or has been prompted by human. And that is where the company called Copilotkit came to our rescue by designing a protocol called Agentic UI protocol. In fact, There are a lot of SDKs and source codes in the documentation that you are looking at the moment. And this documentation, most important thing that you need to understand about it is not about the code that is provided for you. The code that is provided for you is just for you to really get up and running as fast as possible. But I want you to understand the technical implementation of this AGUI protocol. It is a protocol. It is not a source code. So I'm going to explain it bit by bit. So one of the things that we had problem with is that things are happening on the front end and things are happening on the back end. But to keep track of things that are happening in the back end, where the AI systems live, the agent execution tasks there, it is really difficult to make a bidirectional communication between the agent and the front end so that user is updated of what the agent is doing and user can give their feedback. Agent can take that feedback. Or if the agent is going off the rail, agent is doing something that is wrong, user can direct it to where it should go to. But until now there were no clear answer to this. But Copilotkit has just introduced what is called events. So at the basic level, each and every time that user or the agent is doing something, agent is emitting events. And these events are transferred back to the front end for the front end to update its UI. So the thing is, we are having a lot of many ways to communicate with the backend. One of them is through server-side events, or you can communicate just through direct HTTP call, or lastly, you can communicate through the WebSockets. But the third thing in agentic UI or AGUI protocol is that the backend or the agent and even the front end has to communicate through 16 standard events that has been defined here. So some of those events, for example, if you can look at this flow, involves run begins, that is the agent has been initiated, that is run has been started, or execution has stopped, or run has finished. At some point you will say run has finished, or it can be run has finished, or it can be it ran into an error and then there is run error. And then all these are being transferred to the client. So as you take them to the client now updates its user interface. The user interface, or what the user is saying, is now updated to reflect what is happening on the agent. And this makes both the backend and the front end keep a tight sync. Now let's move on step by step. The agent starts by initiating run started. The client will start the loading spinner. And then at some point, a step is executed. For example, it is searching the web. And then the client now updates the screen and say we are searching the web. And then if another step is executed, or if the searching the web is finished, then we update the client, and the client also updates its state so that user can see what is happening until all this is finished through the 16 set of events. I will leave the link to this article in the description, but these events are related to run, such as run started, run as finished, or run error, or step started, step as finished, or step error. And then we also have text message events, such as the text message has started streaming, text message content is now being delivered, or text message streaming has ended. Those are also some events that you can see with the message. And there is a lot of documentation on what these events are about, or what this message content is about, that will really help you to update your UI based on what the backend is doing. But now if we look at what is the most important thing of all of them, is tool call. Tool call is just like the core or the heart of the agentic systems. If agent cannot take action, then that one is just an LLM wrapper that just receive prompt and respond with something like what really it cannot do anything. So taking action is the core of agentic systems. So for the agent to take action, it always needs to call tools, or tools are just HTTP functions that are made available to the agent so that it can execute them at each and every time it wants. But the three main events that are emitted during the tool execution is tool call as started, and then provision of tool call arguments, and then tool call as ended. And they are all events and documentation that I will link down below so that you can look at. And then we also have state management events, so that we always need to show snapshot of the state so that user or the event, the patterns or the front end is always updated and in sync with what the model is doing. And then I think the most important thing to understand there is the events in AGUI protocol. But if you look at core architecture of how it is, you can also look at sample source code so that you understand better. I will leave this straight below. But the next thing that I want to discuss is what is called AGUI compliant. What is AGUI compliance? AGUI compliance is a system, either backend or frontend, that has been designed to comply with the designations or the recommendations of AGUI protocol. For example, Copilotkit is one of those front-end development SDKs that I can call to be fully AGUI compliant. So it connects to backends that are also AGUI compliant, and they communicate through all the set of events that I've just explained. So the most important thing that you have to understand is events. Events is the core architecture of bidirectional communication between the backend and the front end in the AGUI protocol. And if you look at some of the examples that have been provided for you here, are examples that use agentic SDK. One of the most popular agentic SDK is LearnGraph. Another one is Crew AI, and all of them can be downloaded, or you can reference them through the documentation that I'm going to leave down below. And then if you look at things that are happening, you can go to Dojo and you can reference the documentation. I'll leave it down below. But I want to discuss about my current workflow and recommendation. First of all, my recommended AI SDKs or agentic system SDKs that you can use to develop your system. One of them is Pydantic and another one is Agno SDK. Pydantic is good because it is highly clean compared to others such as LearnGraph and even Crew AI. It is very clean and it's low level, especially if you need much control. But the problem is that now it's low level, you also need to write substantial amount of code for you to achieve the same thing that you could have achieved using few lines of code if you really used a fully fledged AI agentic system such as LearnGraph or Crew AI. So you have to balance the trade-off there and look at the system that you are developing, how involved in that system, and if this is something that will be very suitable for your system. So Pydantic also provides a lot of other integrations such as model context protocol and even AI A2A protocol out of the box. It also provides examples on how to do retrieval augmented generation and how to do the streaming and how even to host it using Fast API. And the first thing that you have to understand is that Pydantic is also highly integratable with their logging and debugging system called Pydantic Logfire. That is one thing that you need to understand, is that most often when your AI system or agency system is in production, then you always need to monitor what is happening and whether it is producing good results as you want. And Pydantic Logfire is a good instrument when it comes to that. But it's not always a possibility that any system that is being developed will be developed by this low-level system like Pydantic, because that one is writing insane amount of code. That is why I have to provide a second recommendation called Agno UI. You know what, guys, one thing for sure, and one thing that you will know with me is that I like things which are fast, but then Agno is blazingly fast. It is one of the fastest AI SDKs out there. In fact, it is 10,000 times faster than LandGraph. I know this is just Agno speaking, but also you can understand. Many people have recommended online, and I've read a lot of documentation to show that this framework has very little memory footprint and also is blazingly fast compared to old systems such as LandGraph. And in fact, a better thing or good thing with it is that it provides integrations to almost anything that you need. It integrates with almost all the vector databases, provides almost all the examples on how to structure your agentic systems, including how to structure them using teams, provide toolkit and integration to almost all other model providers that you can check about. It provides access to memory, storage, workflow, evals, embeddings, and everything you can talk about. And in fact, if there is anything that you are confused about, then they have a very good, helpful AI chat system here that you can always ask it anything about this documentation or anything you need really, or any information about agentic system or the best practices how to use it, and then you will just use it out of the box. And recently they have also integrated the support for AGUI SDK. Sorry for that. And with this integration, Agno is the forefront of one of what I can call the best AI SDK that you can find about. In fact, recently I will be announcing my startup that is based on video editing and video generation and optimizing your YouTube channels, and it will be based on Agno SDK. So Agno SDK have given me a very powerful way for me to structure my project. It doesn't go so low level like Pydantic AI and not provide useless wrappers like LandGraph. But this SDK is still very versatile and very powerful, providing almost everything that you need, including models and reasoning capabilities, while maintaining a highly performing interface that you can tweak to your needs. So that is all my review that I have about Agno SDK, Pydantic, and AGUI protocol and how to use it. But one thing that I would recommend is that you can check on Agent UI provided by Agno. This will help you know how to structure your Agno project and how to structure your Agno agent and SDKs so that you always have no issue building your next dream project. That is it for guys for today. Until next time, bye.